Here from Chapter 14, number 51 of McMurray 6th edition chemistry book, we're asked to identify which of the following pairs has the stronger conjugate base. So these are acids, all right? And we want to think about the conjugate base of both of these and then try to figure out which of those conjugate bases is stronger. Well, there's kind of a shortcut or a trend that you need to use or be aware of, and that's listed here under the key points. If you have a stronger acid, it's going to make a weak conjugate base. If you have a weaker acid, it's going to form a stronger conjugate base. So it's inverse, okay? So H2CO3 is carbonic acid. This, of course, is in our sodas. It's a weak acid, okay? And H2SO4 is a strong acid. So when these two form the conjugate base, they're not reacting with each other, but let's just write the formulas. HCO3 minus is the conjugate base of that. HSO4 minus is the conjugate base of sulfuric. If you're confused about that, watch my other videos. So now we can just look at the stronger acid and say, therefore, this should be the weaker conjugate base, and the weaker acid forms the stronger, I'll underline it, the weaker acid, right, forms the stronger conjugate base, all right? So this acid here has the stronger conjugate base, more basic. Okay, this will become really apparent here in this example here because we have a very simple thing we're familiar with. So HCl is, of course, a strong acid. We use that in the lab a lot in chemistry experiments, titrations, and so on. And HF is a weak acid. We're taught about this, but we probably don't use it in the lab because of its toxicity. But HCl forms Cl minus, right, if it becomes the conjugate base, and HF becomes F minus. Now we know F minus, well, we know Cl minus is neutral, okay? We are saying that HCl is such a strong acid that its conjugate base is so weak it's even neutral, okay? So this is not even a base. If you have a weak acid, you form a weak, well, a stronger base, okay? A stronger base. So F minus is going to be the stronger base, HF, all right, is the acid that forms the stronger conjugate base. All right, so I'm going to write here a weakly basic. All right, here we have HF and NH4, and the textbook tells you to look at table 14.1 and just basically read it off of a table. But I thought I would tell you what the pKa's of these are. The pKa of HF is listed as 3.46. All right, and the pKa for ammonium ion is 9.26. All right, probably another key point I should have put up here. Well, I have it on here already. All right, the lower the pKa, the stronger the acid. So if I look at these two substances here I've written down, HF is the stronger acid, okay? We want to select the weaker acid because that's going to be the one that forms the stronger conjugate base. So which of these is a weaker acid? The higher the pKa, the weaker the acid. And this is going to form a more basic conjugate base. All right, so that's the circled choice there. Let's also work with pKa's in our next problem here. They also say refer to table 14.1. HCN has a pKa of 9.31, and HSO4 has a pKa of 1.92. Wow, that's low. This is very acidic. Okay, much more than this, and this is weakly acidic. Okay, so let's go back up to our main point. The weaker the acid, the stronger the conjugate base. So which one of these is weaker? The larger the pKa, the weaker the acidic. And so this is going to form a more basic conjugate base. All right. I hope these key points help you in working through some of these problems in the future. Thanks for watching.